Here we go. And we are going to go ahead and start the webinar. And they should be trickling in now.
Good evening, everyone, Pinellas County Schools, students and families. My name is Mrs. Noun. I am the Elementary Science Content Specialist, and I am so excited to offer this virtual event. I'm hoping that everyone had a smooth day today at home, and I'm so excited to have such a great turnout tonight. So enjoy this evening.
Thank you so much. Hi, everyone. Once again, welcome. We are so excited to have you meet our scientists tonight. The scientists in every Florida school and Pinellas County School District are presenting scientist Lydia Kivrak with the University of Florida's Department of Geological Sciences. She's here this evening to talk about life in the universe with us. You can use the chat feature at any time to write questions that you have for Lydia, and we'll be sure to get those answered before the program ends tonight. Again, you can use the chat feature to do that. Before we turn things over to Lydia, I wanted to quickly mention to all of our teachers and schools on the call tonight that you can always have a scientist speak directly with your classrooms on any subject or content area by simply visiting the Scientists in Every Florida School website. We're a free program housed within the University of Florida with a mission to engage Florida K-12 students and teachers in cutting-edge research and scientists' experiences and role models like tonight. So we hope this inspires you. And we're going to go ahead and turn things over to Lydia to get things started at this time. Lydia, I'm going to stop sharing my screen and take it away.
All right, great. Thanks for having me. So yes, I am Lydia Kivrak, and I will be talking to you today about life in the universe. Now, if you looked at the sky earlier this week around 4 a.m. on Tuesday, I think it was, many of you were probably asleep, but if you'd looked up into the night sky at around that time, you would have seen something really weird, and that was that the moon was completely red. Now, why is that? I just wanted to call this out because this is a pretty unique event that happened this week, and this was a lunar eclipse. And this is what happens when the Earth's shadow falls completely on the moon, blocking the sun's light. You see, the Earth travels around the sun, and the moon rotates around the Earth. And because of this process, sometimes the Earth can come in between the sun and the moon, blocking out the light from the sun. But the Earth is not the only planet that does this. There are multiple planets in our solar system that all rotate around the sun. And the sun is a very large object in our sky. It doesn't seem like it when we look at it from here, but it is really, really large. And all of the planets in our solar system revolve around it. Now, who am I? My name is Lydia, and I am a grad student at the University of Florida. I am working on my PhD, and I'm a geologist. This means I enjoy going outside. I like looking at rocks, picking up rocks, and then taking them back home to work in the lab. And in my free time, I also enjoy doing normal people things like theater, singing, and all sorts of fun hobbies. I enjoy drawing. I'm not very good at it, though. And I am an astrobiologist, and this means that I study ways to detect life on other planets. So, in short, I'm kind of looking for aliens. However, you might think that when I say I'm looking for aliens, I'm looking for something that looks like this, a little green person in a flying saucer. However, that is not what I am looking for at all. I am looking for evidence of microbes on other planets. And now these are really teeny tiny organisms that live everywhere on Earth, and they are really simple. Humans, we're like really big and complex. We have all these limbs and brains and hearts and stomachs. We're really complicated. But microbes are so tiny that you can't see them, and they're really, really simple. They're the simplest forms of life we know. And so when we're looking for life on other planets, we want to look for the simplest forms of life, because simple forms of life like microbes can survive in really dry, really extreme environments with very little water and food. Much like the surface of other planets, they would be really hard for us to live in, but not so hard for microbes. And so when we're looking for life on other planets, we have to look for the things that microbes and us need. All life needs food, water, and the building blocks of life to survive. And all of these things need to be in the same place for a microbe to live. Needs something to eat, something to drink, and its body needs to be made out of something. And so a place that has all of these ingredients for life could be called a habitable environment. Earth is a habitable environment for sure, but we don't really know about the other planets yet. They might have been habitable environments, but maybe not. And so what astrobiologists like me do is that we look for biosignatures. This is a feature that can show evidence of life in the past or in the present, and there are a lot of different kinds. One really famous type of a biosignature you might have heard of are dinosaur fossils. This is not life that is present today, but fossils show that there was a big animal that lived in that place at some point millions of years ago. But fossils are not the only kinds of biosignatures. Little tiny microscopic microbes can also form fossils. Either they can be singular microbes that can only be seen under a microscope, or microbes can live together in large colonies where they all work together to survive. And when microbes live together like this, they can form large mats of slime, essentially. And when these microbes live together, the layers of slime can be preserved within rocks. So if you see my mouse here, all of these wavy lines are fossils of a colony of microbe slime all living together billions of years ago. And so in addition to looking for microbial fossils, we can also look for the building blocks of life. These are molecules that make up the life as we know it on Earth, and that's what I look for. Now, I have a poll for you guys, and this includes these 3 pictures. Now, one of these pictures was taken from the surface of another planet. Can you guess which one? All right, I think I'm seeing sort of a consensus on the poll now. It seems like a lot of you think that C was taken on the surface of another planet, but there's still a lot of you that think that A or B was taken on the surface of another planet. And the answer is correct. It was C. C is a picture that was taken on the surface of Mars. But the point of this exercise is that it's not obvious at first glance, really, whether A, B, or C was taken on the surface of another planet. And this is because there are places on Earth that look a lot like Mars at first glance. Picture A was taken in Antarctica. Picture B is a picture from the Atacama Desert, and picture C is a picture from Mars. All of these places are really, really dry, and Antarctica is really cold, just like Mars. And so these places are called terrestrial analog sites. And so these are places on Earth that are similar to environments like Mars. And Going to Mars is really hard, and getting rocks from Mars is really hard. But if we take rock samples from places on Earth that are a lot like Mars, we can study other planets a lot more easily. And that's what I do in my lab at UF. I have rock samples from places that resemble Mars today and Mars in the past, and I look for evidence of life in them. And of course, since these are Earth rocks, there are microbes living in them. And then we can compare those results that I find with what we see on other planets to see if there are microbes there. There might not be, but there might be. And so we can practice detecting life on Mars by doing the same experiments on Earth rocks. And this helps us figure out the best places to look for life on Mars, the experiments that we should do there, and what results we can expect to see. And we have rovers that are on Mars that do just that. This is a rover called Curiosity, and it has a machine that's really similar to the one that I have in my lab. And so it can do the same experiment on real Mars rocks to see if we can find the building blocks of life. Now, that's what I do, but let's zoom out about 5 billion miles or so. This is a picture of a very, very tiny segment of the night sky that is blown up to 1 million times the size. And this is through the eyes of a giant telescope. And what you're seeing here is millions of galaxies. And so each one of these spots of light here is a collection of billions of stars. Now, let's zoom in a little bit. Here is one of these galaxies. This is a picture of the Andromeda Galaxy, which is a galaxy that is very similar to the one our star lives in. The Andromeda Galaxy has this really cool spiral shape and is really close to our own galaxy. Galaxies can also be elliptical shaped, or they can also be really irregular shaped. But the thing that galaxies have in common is that they are collections of hundreds of billions of stars. We think that there are 100 billion galaxies in the universe, which is, if you're not familiar with billions, that's 1 with 9 zeros at the end. And each galaxy has hundreds of billions of stars. Our own galaxy is 100,000 light years across, and a light year is the distance that light can cross in a year. You might think that light isn't something that travels really fast. Light is just, you turn a switch and the light comes on. But when you do that, it may seem that the light is turning on just like that in an instant, but it's actually traveling at a speed that is so fast, you can't tell that it's traveling. So light can travel about 6 trillion miles in 1 year. And the galaxy is 100,000 light years across. So it's pretty big. And so here is a picture of a small fragment of all the stars in our galaxy. We're zooming in even more now. And each one of those stars is its own solar system, like our own. Some stars have more planets than our sun, some have less, but each one of those stars is just like our sun. Now, what is a star like our sun? It's a ball of hydrogen and helium gas, and it uses hydrogen as fuel to burn, and it releases light. So they're kind of simple, but they're really amazing because stars can live for billions of years, and stars like our sun release all of the energy that plants and animals need to live. And there are a lot of different sizes of stars. So in this picture, this is a size comparison. Our star is this little tiny dot. And here are some of the other stars that we know of in our galaxy that are larger than our sun. So yeah, so when you look up at the night sky, some of those stars up there are really, really big. And stars, kind of like humans, they go through life cycles. The largest stars when they run out of hydrogen to eat, like you may when you run out of your favorite snack, they get kind of cranky and they get really annoyed, and their faces turn red and they explode in a giant supernova because they're really angry that they don't have their favorite snack. And sometimes they don't get as angry when they don't have enough of their hydrogen to consume. Sometimes they just gently puff out their outer layers to form a planetary nebula of gas and dust. And the really largest stars form black holes at the end of their life cycle. And black holes, we don't really quite understand them super well yet, but black holes are pretty cool. They can suck up everything because their gravitational force is so strong, and not even light can escape a black hole. But most stars are not that large. Very, very, very few stars will form supernovas. For the majority of stars, when they are no longer able to burn fuel, their outer layers spread out and they become a cloud of gas and dust that eventually can come back together and form a new star in the cycle of star life. The gas and dust in these planetary nebulas can also form planets. Like in this picture here, there's a brand new star that's in the middle, and all of these rings are where the new planets around this star are forming. And that's how you form a solar system. Ours is about 7 billion miles across, which is pretty large. It would take you, if you're in a road trip, it would take you about 10,000 years to drive across in a car, which is definitely way too long for me to be stuck in a car with my parents for 10,000 years. I don't know about you all. However, you could fit about 800 solar systems in one light year. Remember the light years I was talking about a minute ago? That's how big a light year is. And our galaxy is 100,000 light years across. So galaxy is pretty big, but the solar system is also unimaginably large. And that's how you form a solar system. This is ours. This is not to scale. Mercury is a really tiny planet and Jupiter is a really large planet. But this is all the planets in our solar system that circle around our sun. And I'll go through them one by one. Mercury is the closest planet to the sun. And some fun facts about Mercury is that it's really hot there, and a year is only 87 Earth days because it is so close to the sun and it goes around really fast. And a day on Mercury is equal to about 58 Earth days, which is more than half a Mercury year. And it doesn't have an atmosphere like us. So if you went to Mercury, you would not be able to breathe any air. And so it's boiling hot during the day, and it's freezing cold at night, like a desert. Venus is the next planet in our solar system. It has an atmosphere, but you wouldn't want to breathe this atmosphere either. Its atmosphere is toxic and traps heat with a greenhouse effect, and a day on Venus is longer than a year. Venus is 864 degrees Celsius on its surface, which is hot enough that it would melt lead. Cars on Venus would just melt into puddles of liquid. So not a very pleasant place to visit. The third planet in the solar system is Earth. Earth is also a planet, and that's where we all live on. And this is Mars. This is the fourth planet in our solar system. And Mars is really cool because it has some of the largest volcanoes in the universe. These dark spots here are volcanoes. Its volcanoes are about 3 times as large as the tallest mountain on Earth, which is really incredible, considering that Mars, the planet, is only a quarter the size of the Earth. Mars also has, or had, rivers. This structure here is sort of this snake-like thing that would have been a river with flowing water on it a couple billion years ago, which is incredible because on Earth, all life needs water to function. So if there was water on Mars at some point, was there life? Well, maybe, and that's why we've sent a bunch of different rovers to explore the surface of Mars to answer that question. This little rover up here, Sojourner Truth, was sent in 1997, and it was the first rover to explore the surface of Mars. Then Spirit and Opportunity were sent in 2004. They were designed to last 6 years. I remember they landed when I was in 2nd grade, and I was very excited. And then a couple years later, I asked my mom, are those rovers still going? And she said, yes, they are. And those rovers kept going until I had nearly graduated college. They lasted for 14 years. They were meant to last 90 days, really. And this is Curiosity, which is currently exploring Mars. It's still there. And it is exploring an ancient lake that was filled with water billions of years ago. And this is Perseverance, the newest addition to the fleet of rovers on Mars. It landed in early 2020, and it is exploring an ancient river with a little helicopter friend named Ingenuity. Moving past the 4 inner planets, further out in the solar system, the planets are a lot larger and have a lot more gas. And so these planets are called the gas giants. This is Jupiter. It has 79 moons. And this is Saturn. It has 82. We have a moon, but our moon is not the only moon in the solar system. This is another picture of Jupiter, which is really cool because it has these white spots, which are all storms. If you've seen pictures of hurricanes, and by the way, I hope everybody, got through the current one that just passed over Florida okay, and that everyone is safe and has power. But Jupiter also has hurricanes, but the hurricanes on Jupiter are about the size of Earth. So I'm glad that this one was relatively small and not like the ones on Jupiter. And so the last 2 planets at the edge of our solar system are Uranus, which is unique because instead of rotating faced up, it lies on its side, and Neptune, which is the farthest planet from the sun. And I'll wrap up here with a little chat about a couple of the moons of Jupiter and Saturn. So we have a moon, but Earth is not the only planet that has moons. A lot of other planets have moons. And while the gas giants like Jupiter and Saturn might not be the best place for life, considering all those extremely large hurricanes that are larger than Earth, some of the moons of Jupiter and Saturn might actually be the perfect place to look for life in the future. Ocean worlds like Europa and Enceladus have icy shells that, this looks like it's really snowy and it might be a really fun place to go sledding, but underneath that icy shell, we think that those 2 moons have oceans of water that is liquid today, which is really cool because even on Mars, we don't think that there's water today. We think that there might have been water billions of years ago, but these moons, we think, have water today, and they have geysers, which shoot the water and ice out into space. And so if we wanted to look for those building blocks of life that I study, we wouldn't even have to go to the surface. We could just send a spacecraft, fly through these plumes, and see if those building blocks are in the water that's being spewed into space. And so we think that some of the most unique and earliest forms of life on Earth lived on the seafloor at hydrothermal vents. These are places where really hot water is coming out from the interior of the Earth at the bottom of the ocean. And that brings with it warmth and chemicals that microbes can eat. And so we think that if there are geysers and there's water on these icy moons, maybe there could also be vents. Maybe there could also be microbes. I don't know yet, but that's what I'm working on finding out. And here's an artist's depiction of what we might find if we send a submarine there sometime in the future. hopefully it'll be during my lifetime that we explore down there. So hopefully we will make amazing discoveries regardless of whether or not there is life on these icy moons. And yeah, there is so much to explore in the universe, and thank you for listening to me talk about my little piece of it.
Thanks so much, Lydia. That was amazing. And I have to tell you, we have no shortage of questions. They're still coming in, and we probably won't get to all of them, but what we can always do is forward any questions we've missed to Lydia, and perhaps she can answer them and I can follow up with the district to get them out to our listeners. So I'm going to start off with a couple really good ones here. There's a number of people, Camilla, a third grader, and a number of students are asking about light years. If you can explain them again as far as what they are.
Okay, so let's move away from light for a second and think about sound. So if you are standing on one hill and your friend is standing on another hill really far away, and you yell at them, you might hear a little bit of an echo. And that's because the sound that's coming from your mouth is hitting the hill and then coming back at you. And light can work in kind of the same way where, you know, if your friend and you are standing right next to each other, it doesn't seem like sound is something that travels. It's just something that is. But that's because it is moving so fast that you can't tell that it's something that moves. And light is kind of the same way, where if you turn on a flashlight, it looks like the light is coming from your flashlight instantaneously, but it's actually not. It's just happening so fast that you can't tell the difference. And so that's what happens in a light year, is that even though light travels so fast that you can't tell the difference, it still takes a whole year sometimes for light to travel a large distance. And so, for instance, the sun is actually 4 light minutes away. And so the light that is coming to us from the sun left the surface of the sun 4 minutes ago. So hopefully that makes a little bit more sense.
That's fascinating. Thank you. Blake and Trent have a question for you. They want to know if you've ever seen real rocks or artifacts from Mars.
Well, I have seen pictures of rocks from Mars that the rovers are taking, and we do have one kind of rock from Mars, and that's Martian meteorites. So asteroids, they can hit the Earth, like the asteroid that helped wipe out the dinosaurs. And asteroids can also hit the surface of Mars or the moon. And when this happens, lots of dust and rock can get exploded and spewed out into space. And then some of them can come land on Earth later as meteorites. So we have a couple of meteorites that were originally from Mars, got hit by a giant asteroid, and then spewed out into space before eventually landing again on another planet like our own.
Excellent. There's a couple of kids that are asking about, how do we know the age of things? We mentioned that things are billions of years old. How do scientists date different items like rocks, or you mentioned fossils, for example?
So there are a lot of different ways that scientists can date objects. And a couple of ways include different chemicals and different atoms that are within the objects. So for instance, with fossils, sometimes molecules that are in living things enjoy using atoms that are lighter than atoms that are not as light. And so we can measure the chemicals in some of these rocks to understand whether or not there was life there. And we can also look at the different chemicals in the rocks to see because not all chemicals last forever, not all atoms last forever. And so some atoms are radioactive and have more and weigh a lot more than other atoms. And these atoms break down over time. So if we look at a rock and we see, oh, there's a lot of these really like big heavy atoms in them, that can be an indication that it's something that's really old. And we can use math and equations to determine this really accurately, instead of being like, oh, well, there are a lot of them, that means it's billions of years old. We can actually look at that, we can measure that, and we can plug what we are seeing into a math equation. Math is useful, I promise. And then we can use that to see, oh, well, this is about 3.7 billion years old.
Adam just said, I really like this stuff, just so you know. Olivia and Quinn have kind of related questions, and it's also involving age of items. Quinn's asking, is it true that the sun will die in 4.5 billion years? And Olivia actually wants to know, how old is our sun?
Yes, so the sun is about 4.5 billion years, and it has about 4.5 billion years to go. That's about right.
Declan wants to know, are any of the biosignatures that you're looking for, would they be alive still?
Well, if we were looking at the icy moons, where I talk about a little bit at the end, they could be alive there. There's liquid water there, and microbes get really thirsty like we do, so we don't think that life on Mars would be there today. If we find life on Mars, we think that it would be past life on Mars, so fossilized microbes. But biosignatures from these icy moons with liquid water, who knows what we could find.
Fantastic. There's some folks that have asked about how far have we dug on the planet Mars, and also a very interesting question about what would happen if we took molecules or bacterias or other things to Mars. Would we be able to create life?
Those are great questions. And so if I go back to one of my really early slides, we have dug into the surface of Mars, but we have not dug that far. Where did it go? So this picture here, this is a drill hole that the Curiosity rover made on the surface of Mars. And so we have not dug that far. We have a probe that I didn't talk about that is there not to detect life, but to understand earthquakes on Mars, that has a metal pole that it dug into the surface of Mars pretty far, like a couple of meters. But in terms of searching for life, we've only gone a few inches into the surface of Mars. And that's actually a really exciting question, because a lot of scientists in my field think that looking for life underneath the surface of Mars actually might be the best place to look, because there might be liquid water under the surface of Mars. We don't know, but there might be.
I think we might have future lab mates on this call for you.
Yeah, no, that was a great question. And the other interesting thing about this picture is that Mars is the red planet. It's famous for its sort of rusty red surface, and this is because there is literal rust in the soil, because there's a lot of iron there. But if you just dig an inch or two under the surface, you see that this dust and rock is gray, and that's because the atmosphere is not in contact with it, and it's not causing it to rust. So that's something that's just really cool.
You've just blown some
Sorry,
minds.
there was a second question there that was also really good.
The question was about bringing life forms, bacteria or other microbes to the planet. Could you get them to exist? Or to continue to
maybe
exist?
could, and that is why all of the rovers before they go are really, really intensely cleaned, so that we don't do that by accident. Because if we were to bring microbes to Mars and we were accidentally letting them run free on the surface of Mars and they survived, and then a scientist like me later goes over there and wants to look at a rock and picks it up and is like, ooh, I found life on Mars, then no, you haven't. You've just found life on Earth that was brought to Mars, which isn't nearly as cool. So we want to try and not do that as much as possible, so that we can understand what's going on the surface of Mars before we contaminate it.
Very good. I think we've got time for a couple more questions. And as I said, sadly, there are so many questions coming in. So we're going to have to get these to you, I think. The questions I'm going to leave you with, number one here is, speaking of the rovers, is there any live feeds on these rovers that people can watch, or is this something that they plan to do with future missions?
So there isn't a live feed, and the reason for this is that so the rover, it sends information back once a day. We're not in constant communication with it because again, it goes back to that light year thing. So Mars is not that far away from Earth in terms of light years, but it is a couple of light minutes away, like the Earth is far away from the sun. And just like light, radio waves and signals also move at that same speed. And so when we get things from Mars, it's a couple minutes later than what actually happened. And so we can't actually control the rover in real time because it would crash into something. And so because of that, the rover just tells us what it did at the end of each day, and then we give it its instructions for the next day. But there are lots of pictures and data that you can see from the surface of Mars that's on the NASA website. And there is some video with Perseverance, the most recent rover. This was the first time that we were able to send back video footage because images were taken as the rover was descending. A lot of images were taken really close together and then were stitched together to make a video. And so there's a video of the parachute opening and of the rover as it's looking down on the ground and landing, which is incredibly cool. And I highly recommend everybody check out that video because it's spectacular.
So I'm going to squeeze one extra question in, but Magdalena, she's asked this several times in the chat box. I've got to get this to you. Wants to know about the Kepler-19 solar system. Can you briefly tell us about that?
Oh, I am not the biggest expert on exoplanets. Is that the one with 7 Earth-like planets? I
don't know.
So
Magdalena,
yeah, there are a lot of different...
do some investigation.
So for those who may not know, like Earth is not the only planet around our sun, and Earth is not the only planet with moons in our solar system. Those other solar systems also may have planets, and those planets are called exoplanets. And all the exoplanet systems are often called Kepler followed by a number because they were detected by the Kepler spacecraft. And there is one Kepler system that I think has 7 planets that we think are within the zone where life would be possible, because it's the zone where water would be liquid because it's not too cold, it's not too hot, it's just right, like Goldilocks.
Fantastic.
So yeah, that's a really exciting field of study, that it's not just the planets in our solar system. It's important to keep in mind that there also could be life on planets outside our solar system.
Excellent. So our last question, and this is really just to inspire those future scientists that are on the call with us tonight. What would be a piece of advice you would give to anyone who's very interested in the concepts and the content that we've talked about tonight?
Well, there's a lot of information on the NASA website. I really got into space science because I watched this one documentary about the planets when I was little over and over because I just loved it. But I would encourage anyone who's just interested in science is to just go outside. We just had a really big rainstorm, big hurricane. Once it's safe and it's light outside, maybe go outside and see how all the intense rain might have changed your community or the land around your house. Maybe there is a new tree that's down. Maybe there is a pile of mud that wasn't there before. Maybe there are critters that are living in your gutter that aren't usually there. So definitely go outside and just observe the things in the world around you and ask questions about them, and keep track of that.
Thank you.
Stay curious.
So this has been an absolute pleasure. I know I'm curious, and I'm going to be looking at some things after tonight's call. So a very special thank you to Lydia for joining us today, for the District of Pinellas County and all of our listeners. We appreciate your time with us today, and we hope you've had a great time with us. We hope to see you again soon. Take care. Bye, everyone.